Welcome to my calculus class, and in this class we're going to look at limits of greatest integer functions. So before we go more into the limits of greatest integer function, we will first look at what are greatest integer function. So we said another use of the one-sided limits is that of investigating the behavior of step functions. Then what are step functions? Step functions are the greatest integer functions, and those functions when you graph, you have them in these forms. And we're going to look at them. We're going to see how these functions are actually called the step functions. So, we say another way or another use of one-sided limit or one-sided limits is that of investigating the behavior of step functions. So one type of step function we want to look at is the greatest integer functions. There are other types of step functions. Now let's define the greatest integer function. We said the greatest integer function, this is the notation now, and in some books you will see notations like double bracket like this, right? You will also see it like this. You can also see something like this, and then you also see a single bracket for greatest integer. All of them are correct. So the greatest integer of x, right? It is that number that is less than or equal to x. The greatest integer of a number x is that number that is greater than or equal to x. So we say the greatest integers n such that n is less than or equal to x. Now there are two basic properties that we need to observe when it comes to the greatest integers. One property is that if x is a positive whole number or a negative whole number, then the greatest integer of x is just equal to x. But if x is a decimal number, then it means that the greatest integer of that decimal number is the nearest whole number to the left of the decimal number. Because mind you now, we are not looking for decimal numbers, rather we are finding greatest integers. We are finding integers. So let's look at a few examples of evaluating greatest integers. But before we do these examples, let's draw the graph, the number line. Let's draw the number line. It's important to draw the number line because the number line guides you in identifying those greatest integers that we want. So let's say this is the center point, this is 0, and let's say this is 1, this is 8, and so forth, right? So now, the first example says that we must find the greatest integer of 5. What is the greatest integer of 5? Since 5 is a positive number, the greatest integer of 5 is just equals to 5. But why? This is 5, right? Now, identify some greater number of 5. 6, 7, 8, 9, 10 in the right of 5 direction. All those numbers are greater than 5. And all those numbers are also integers. Now, because all these numbers are greater than 5 and they are also integers, and 5 is also an integer, we cannot take 6. We take 5 itself because 5 is an integer. So all of these numbers from 5 all the way in that positive direction, they are all greater integers. Mind you, this is a very important note. when you are finding greatest integer of a particular number, that greatest integer should not be more than the number itself. It should be the integers that is either less than the number or it is equal to the number. So you see, 4, 3, 2, all these are integers. All of these are integers, right? They are all less than 5. But because 5 is an integer also, so we can take 5 because the notation is that the greatest integer of x is equal to the greatest integer of some n, such that n should be less than or equal to x. So n can either be equal to x or n should be less than x. Meaning the value you can get in there can either be equal to x or less than x. Meaning this 5 can either be 5 or less than 5. So since it is a whole number, it's just equal to 5. So for all of the whole numbers will just be the same. All of the whole numbers will be the same, right? Now let's move to the next one. Question 2 says -5. -5 is also a whole number and -5 is an integer. So it is just equal to -5, right? So even if this was 13, you have -12, it's just equal to -12 and so forth, right? Those are greatest integers. What's about 1.7? Now let's come now. This is 1, right? 1. 1.7 means you are moving this direction right there. Somewhere around here, assume somewhere around here, 1.7. So here is 1.7, for example. Okay, now we in the negative side. This should be this 1.7 around here. So this is 1.7, right? Now, if this is 1.7, the question is, what is that integer that is considered the greatest of all integers that is less than or equal to 1.7? Now, 1.7 is not an integer, it's a decimal number. So let's consider those integers that are in this direction. You have 1, you have 0, you have negative. All of these integers are all less than 1.7. But the greatest of all of them is 1. So 1.7 is just equal to positive 1. So let's continue with question 4. Question 4 says 1.8. What is the greatest integer of 1.8? Now again, let's look there. 1.8, let's consider 1.8 around here, right? So if this is 1.8, which is almost at 2, what is that integer? That integer that is less than or it is equal to 1.8. Mind you, 1.8 is not an integer, it's a decimal number. So let's look for integers that are less than 1.8. You have 1, you have 0, you have -1, you have -2. Of all of these integers, which one of them is the greatest? 1 is the greatest. So the greatest integer of 1.8 is just equals to 1. What's about 0.6? This is 0, right? So 0.6, assuming it's written. So let's say this is 0.6, right? Now, if there is 0.6, what are those integers that are less than this 0.6? So all of these integers, right, are less than 0.6. 0, 1, 2, 3, 4, and so forth. Amongst all of them, which one of them is the greatest? 0. So 0.6 is just equal to 0. What's about 2.3? So come here. This 2.3, assuming that 2.3 is right here. 2.3. So 2.3, right? What are those integers that are less than 2.3? You have 2 itself, you have 1, 0, and so forth, right? So from 2 all the way in this direction, the negative direction, what is that integer that is considered the greatest to all of them? So 2 is the greatest. So The greatest integer for 2.3 is just equal to 2. Now let's move to the negative portion. Why don't we have negative 1.6? Now this side is the negative side. So negative 1.6 should be somewhere around here. So negative 1.6. Why do we have negative 1.6? What are those integers that are less than 1.6? All of these integers, right? From negative 2, negative 3, negative 4, negative 5, all of these integers are less than negative 1.6. So amongst all of them, which one of them is the greatest integer? 2 is the greatest integer because 2 is greater than 3, 2 is greater than 4, and so forth. So amongst all of them, 2 is the greatest integer. Why is it that we cannot take minus 1? It's because minus 1 is on the right hand side of 1.6. And we said the greatest integer should not be more than the number. So it should not be more than 1.6. So it is minus 2. Minus 2. The next one says 1 over 2. And we know 1 over 2 is equal to 0.5, right? So 0.5 is around here. 0.5. So what is that integer that is not more than 0.5, but it is less than 0.5? It is 0. 0 is an integer. So it is 0. What's about negative 5 over 2? Now let's erase these things. What's about negative 5 over 2? 5 over 2 is just equals to 2.5, right? 2.5. So this is negative 2.5 or 2.5. So negative 2.5 is found between minus 2 and minus 3. So 2.5 is right there. 2.5. So the question now is, what is that integer that is less than 2.5 and is considered the greatest? All of these integers are less than 2.5, but which one of them is the greatest of all of these integers? The greatest is minus 3. So this is minus 3. What's about minus 2.8? This is 2.8. 2.8. So we say 2.8 is around here. Minus 2.8. So all of those integers now that are less than 2.8 are in this direction. Minus 3, minus 4, minus 5, and so forth. So amongst all of them, the greatest one now is minus 3. So here is also minus 3. 4.7. Now this is 4. We consider this to be 4.7. Negative 4.7. So negative 4.7, all of those integers that are less than 4.7, they are in this direction. Minus 5, minus 6, minus 7, minus 8, and so forth. So amongst all of them now, determine the greatest of all is minus 5. So it's minus 5. So that's how we find greatest integers of numbers.